Got the recording. Before we start, we do want to provide a land acknowledgement. We respectfully acknowledge the territory in which we gather as the ancestral homeland of the Beaufort and the island of Newfoundland as the ancestral homeland of the Mi'kmaq and the Beaufort. We would also like to recognize the Inuit of Nunatsiavut and Nunatukavut and the Innu of Nitsunan and their ancestors as the original people of Labrador. We strive for respectful relationships with all the people of this province as we search for collective healing and true reconciliation and honor this beautiful land together. Now, join me in welcoming today's seminar speaker, Sofia Montalvo. Sofia is here with us from Washington, D.C., where she is the SAR Imagery Order Desk Lead at the U.S. National Ice Center. Originally from South Florida, she became interested in meteorology after Hurricane Charley narrowly missed her house in 2004. She earned her Bachelor's of Science in Marine and Atmospheric Science with a focus in meteorology from the University of Miami in 2011, and a Master's of Science in Atmospheric Science from North Carolina State University in 2014. Prior to working for the National Ice Center, Sofia was an analyst at the National Data Buoy Center, where she spent time at sea to recover and deploy several tropical atmosphere ocean buoys along the equator in the Pacific Ocean. Then in 2017, she moved to Washington, D.C. and started working at the U.S. National Ice Center as an IMS analyst. Later, a physical scientist, and this year she became a SAR Imagery Order Desk Lead at the center. With that, I'll hand it over to Sofia.
Thank you for that introduction, Aina. Today I'm going to talk about the scientific support that we conduct at the U.S. National Ice Center here. But first, a little bit of background about the center. We are located in DC, and we are a tri-agency organization. So we have people who work for the National Weather Service, the Department of the Navy, and the Coast Guard, all working together at this one center, all working towards the same mission of safety at sea and also supporting any science in the Arctic and Antarctic as well. So we have this is our general process of creating the products that we create every day and every week. We take in satellite observations, buoy data. We have people at sea giving observations, surface observations, and some radar and other in situ observations. And then we also take in model data and computational data to create our daily sea ice extent and our weekly ice concentration, ice thickness products. And then we also create a daily snow and ice extent product. From there, we can then kind of tailor that down to support different ships or scientific missions in ice areas of the Arctic and Antarctic and also the Great Lakes. So for those high latitude observations, we also support the Interagency Arctic Buoy Program, and we just had our NOAA Corps officer that works here go up to Alaska and deploy several buoys out of a plane into the open water of the ice north of Alaska. And then we also support sail drone observations. They can get close to the ice but not in the ice, so then we provide the sail drone operators with the ice edge there. And then we just started an agreement with SOFAR, which is another buoy data source, and we've deployed 5 of the SOFAR buoys to test if they can survive in the Arctic environment. that just occurred off of the U.S. Coast Guard cutter Healy last month. And we also take in a lot of satellite imagery to create these products. So my job is to order RadarSat-2 imagery and other SAR imagery sources that are commercial, that like ICEX data. It's a synthetic aperture radar is what SAR stands for. You can see through clouds, day or night, and each different band can see a different depth into the ice, which would give you a different view of the features in the ice, like ridging or meltwater, or different aspects of how the ice is has formed. So this is a good example of all the SAR sensors as the observation, and then we can take that and create different things off of it, such as the sea ice drift products, and that kind of, as long as two SAR images are overlapped, you can see how the ice has moved over that time period. And that's kind of what the computational data sources that we get from the raw images itself. So I'll get into a bit more of the product suite that we create. These are the marginal ice zone product is a daily product where marginal ice is anywhere from 10% ice concentration to 80% ice concentration. And then the pack ice is 80% to 100% ice concentration, which is that red in the central Arctic on the left there. And then bi-weekly, we create a sea ice concentration product and a stage of development product, where it gets a bit more detailed, looking at all the different ice types that have formed in the Arctic and Arctic. These three products are created for both the Arctic and Antarctic. Something that's super interesting for certain scientists, and we work together with a scientist at NASA to track very, very large icebergs in the Antarctic. That has to be at least 20 nautical miles squared in area, and we're tracking about 60 large icebergs at the moment. And this is a product that goes out weekly. Usually they don't move too fast, so it's kind of easy to find them. But sometimes if the current picks it up, they can move quite a few tens of nautical miles a day. And so it's really interesting to see how they move and how they melt. And then we also do a daily analysis in the wintertime of the Great Lakes ice and the Chesapeake and Delaware Bay. And this really affects commerce and maritime safety for these areas, especially since they're always trying to ship products into the Great Lakes during the winter. Now this is the Great Lakes is a joint product with the Canadian Ice Service, and so half the week they create the product, half the week we create the product. And we also have a joint agreement where we share imagery between each other. So this is actually a scientific support that we conducted with the Weather Service in Marquette, and they were supporting the National Park Service on Isle Royale in Lake Superior, which is in the northwest part of Lake Superior. They flew out to Isle Royale and were counting the wolf and moose populations and landing on the ice that was connected to the land and doing some surveys of those populations there. That was a very interesting support of kind of mammals and a little bit of science involved there. And then a yearly mission that we support is the U.S. Coast Guard cutter Healy that goes up to the Arctic, north of Alaska usually. Last year they went for the full Northwest Passage, but every year we support scientists on board the Healy who have who deploy gliders in the water to study the upper ocean, and then also they've deployed under ice moorings that do a full kind of stratified ocean study, and they've also deployed in ice moored buoys that have sensors that drop below the ice into the ocean, and that drifts with the ice, and they can study an array of different temperature and salinity, conductivity information from that area of pretty rapidly changing area of the Arctic. These are pictures on the right of our Chief Warrant Officer, Mike Lattin, who was just on board the Healy last month, and that's him deploying the SOFAR buoy in an open lead up there. And they got to go out onto the ice and kind of have a day of stretching their legs off of the ship. And I've been able to support the Healy in person twice since working here. And then this is another science mission that operated in the Beaufort, the salinity and stratification of the sea ice edge, SASSIE. And while we do support the science missions, the bulk of it was supporting the mariners themselves, which is the research vessel Wolstad that cannot operate in ice at all. It's not ice hardened. So we were really warning them about where the ice was to make sure that they didn't have to interact with the ice at all and still conduct their mission near the ice edge. And we also support the research vessel Sequoiac, which is operating in the Arctic right now. They also support the same people that were on board the Healy, also go on board the Sequoiac. The Sequoiac can only operate in thinner ice, first year ice, or ice that's only been formed since this October. If it's thicker than that, it has a lot of trouble breaking through. And so we provide to them the ice edge and also the different ice types, which is on the right here, labeled with the letter alphanumerical labels there are, and then the moorings that they operated near are also overlaid. So they have all the information they need to operate their mission. A very cool scientific mission that we also were able to support was the MOSAIC. I'm sure some of you have heard of this, where the research vessel Polar Stern moored itself into the ice for a year and drifted with the ice and did several studies on and under the ice over the winter, and they were capable of staying up there for quite some time, and then came out through the Fram Strait to where they could operate out of Svalbard to get their equipment back that was on the ice. And a really big mission that's part operations and part science is ICEX. It's the naval ice exercise that they conduct every 2 years, where they're also operating submarines under the ice and build a camp on the ice and do different studies. These are all the different data sources that we take in to give them a good forecast of how the ice and weather will be over the day, since it's a very risky situation. So we have a micro weather sensor up there. We have GPS trackers on the ice to track where the camp is moving and all the different models. And then we use the SAR imagery to track the flow itself in the image, which is outlined in yellow there. And then we take an auger and also observe how thick the ice is, just in person, you know. And that's a picture of my coworker Alexandra meeting Santa Claus up there. These are all the products that we create for ICEX. It's quite a bit since they're operating in pretty risky situations. This, you can see on the left here is a high resolution optical image of the ice camp circled in blue. And then there's a runway, and they're always operating very small, like bush planes out of Alaska to fly up to the ice camp. And then below that is a picture of the camp with the northern lights above it. And we're also always like worried about the ice fracturing, which you can see on that lower left image. And so we produce a ice fracture risk product for them as well. And then just, I'm not sure if any of you are interested in the Antarctic, but we also support missions in the Antarctic, such as the one conducted every year by the Coast Guard cutter Polar Star, where they do an annual resupply of the U.S. Antarctic program, ice station in McMurdo Sound in the Ross Sea, south of New Zealand. And that's a picture of me briefing the captain in 2019 when I was on board the ship there. And on all of these missions, I've been able to witness several different mammals. In the later slide, you can see a lot of the pictures of the mammals we've seen, like walrus in the Arctic, and minke whales, and orcas and penguins. And we also support the Marine Mammal Laboratory and NOAA Alaska Fisheries Program in their missions to count walrus populations and study the fisheries that are near the ice. A lot of what we do is just operations to support the navigation of those missions. And then we also have scientists helping support our operations to make our lives a little easier. So we talked about, we take in so many observations a day and we do the analysis manually. And from here, it takes about like 2 to 4 hours to conduct the analysis every day. And then on top of that, we create these tailored products for all of these ships that are operating in the Arctic and Antarctic. And they usually require it daily as well. So that can take up a lot of our day as well. And so there's a new initiative to help kind of automate some of the process, at least on our daily, just your baseline product of the daily Ice Edge, because it takes many, many hours of work. So there's a machine learning program happening. We're using only the RadarSat-2 SAR satellite at the moment. We take in the sea ice image, put it through an artificial intelligence with cropping and kind of masking out the land. And then the initial output is just a mask of the sea ice. And then there has been some development since the initial outputs where they've been able to take in the different polarizations of the SAR satellite, and then they can pull out a stage of development of or the ice age, and then also the ice concentrations in the images, and output that automatically. There is a lot of like kind of teaching the algorithm to do this, and so most of the images that have been inputted have been for winter. So now we're also teaching it the fall, like freeze up, and teaching it how to recognize new ice as well, since that can look quite differently than the older ice types that have been there for a year or more, that they look much brighter in the image, whereas new ice looks much darker. And so here's another view of an even further development of how the ice can get pulled out of that algorithm now. It's the initial binary condition, and then there's the daily ice edge and marginal ice zone products can be created now. And then there's the stage of development or age of the ice, and the ice concentration product can now be pulled from that single image. Now from there, it's still not operational, but we're still teaching it the different ice types, and also from there, maybe we can pull it all together and create a larger full Arctic scale product, but that's still in progress. And we also sent it to the U.S. Coast Guard cutter Healy and to the warrant officer that was on board, and so they could test it and kind of let us know if it was showing an accurate view of what the ice was while they were operating up there. So that validation was really key for this last mission. These are pulling out of science a little bit, just some pictures of what I've taken and others I've taken in the Arctic. It's very interesting, the change and the differences every year of how the ice melts out or refreezes in the summer to fall range, in the Beaufort Sea especially. The left image was in 2018, where there was a lot more larger areas of ice and a bit of freeze up in the middle. September is usually when the peak of the lowest ice extent occurs, and then it starts refreezing towards the end of September. And then the right image is from July last year. There were so many more melt ponds and a lot less like larger cakes of ice with snow on top. So we couldn't actually get off the ship at all last year because it was all melt ponds and there was nowhere for us to walk on the ice. And that's a view of where we were. Sorry, so I'll just go back and forth. So that's, if you see at the left, the September 2018, and that's the product from September 2018 of where we were in the ice. And then the product on the right is how the ice technically looked. Like the ice extent was very far south, but the surface of the ice was so melted that there was barely any ice actually there. It was all kind of under a very heavy melt. And then this is a video, I'm not sure if it'll work, but see, of the change of like, from 1984 to 2019, of how you can see how the ice that sticks around for multiple years has reduced in the Arctic, and that really affects how the ice melts out, and also which ships can now operate up there. display. So yeah, that with less and less ice surviving the summer, more and more less hardened vessels can operate in the Arctic, which means more and more people will be asking for support from our center here. And we have a lot of collaborations. I already told you about the collaboration with the Canadian Ice Service. There's also an ice branch at the Alaska Forecasting Office in Anchorage, and several different ones like the Snow and Ice Data Center in Colorado, the Polar Science Center in Washington State, and then the international programs. All of these countries that are highlighted are a part of the International Ice Charting Working Group, and we can collaborate with them. There are people in Denmark and Canada who are conducting the same kind of algorithm study based on Sentinel-1 data, which is another SAR satellite from ESA, and we're trying to maybe combine our algorithms to cover more area of the Arctic and Antarctic. And then here's some cool pictures of what we've seen. I didn't have a good picture of a walrus because they were pretty far away from the ship and I didn't have a zoom lens. But I've seen 7 polar bears and several orcas and penguins and seals and a bunch of walrus hanging out on ice floes. And then I didn't get to see the northern lights as well as that image, but the very small amount of northern lights I've been able to see are very cool. And then the different ice types as well. So the camp is on a multi-year ice floe that is 15 feet thick, but then on the bottom right here, these are ice types that are 15 centimeters thick. And I've seen a polar bear walk on it. It's just insane how heavy they are, but also how spread out that they can walk on the thin ice. And then we've been able to all go on board all of these ships. These are all my coworkers that have been able to operate in the Antarctic and the Arctic to see the ice in person and to observe the conditions in person is kind of critical for training. Yeah, some public engagement stuff. If you guys follow Smart Every Day, I was featured on it 2 years ago. And then Physics Girl featured my coworker Alexandra, and then Chris Redinger is our subject area lead for the Antarctic, and several things that we've been able to do to get our name out and also support science and operations in the Arctic and Antarctic. Yeah, that's all I had. Hopefully it wasn't too rambly, but yeah. Any questions?
Thank you so much. That was really interesting. I know I depend on ice maps a whole lot for my work. So I appreciate all the effort that goes into making them. I'm gonna open it up to questions in the hall, or yeah, okay, we've got one. Oh, okay. Okay, one question that we have is, are the ships rigged with multi-beam sonar?
One of them is, I know the Healy has a multi-beam sonar. The Polar Star doesn't have any science equipment on board, and I'm not sure about the other research vessels, but I know for sure the Healy had one on board. It was, they had to turn it off when they were breaking ice, but whenever they were operating in a lead, they would turn it back on to study the floor.
All right, I got a couple of questions. The first is, what software are you using for image processing and mapping too?
Yeah, for image processing and mapping, we're using Esri's ArcMap. This year, we're testing to upgrade that to Arc Pro. But yeah, the GIS software that we kind of take everywhere and just pull in imagery and map it from there.
Cool. Another is, with how ice is melting nowadays, are you seeing or measurable difference between the new ice that's forming and the older ice? Is there any difference, or is just new ice that you're measuring most of the difference?
I guess, can you elaborate on the measurable differences between new and old ice, or?
Yeah, so you have them differentiated. So are they changing similarly, or?
Oh. Actually, so since every year is different, but it seems like the past couple of years, new ice has formed to the kind of average extent of the Arctic. So Arctic has been covered like fully with new growing into your about meter thick ice. The difference is how much of that ice survives the next summer's melt, which means if not as much of that survives the next summer's melt, then your old ice is becoming less and less concentrated in that area, especially mostly in the Arctic. Antarctic is a different story. They're not losing as much ice, and more ice is kind of like an average amount of ice is sticking around over that summer melt. So yeah, it's just interesting how much is like sticking around and staying in the Arctic.
Cool. Thank you. All right. I think that wraps it up for us. Thank you so much for this very interesting talk. And for everyone that joined us. Our next seminar will be November 21st at 1:30, and that it will be our last seminar of the semester. Yep. Thank you again.
Yeah.